Hey there, campers. Morgan again. We're on page 2 of the Honors Chem lecture outline dealing with thermochemistry. When we finished up page 1, we had just introduced the idea of a system and its surroundings. Now, let's get a little more detailed. An open system. An open system is a system that allows the exchange of matter. Stuff can go in and stuff can come out. A really good example of that is a closed can of Diet Coke that you picked up at the grocery store, and I can't add anything to it because it's closed. Now, what I can do is put it in the refrigerator and let it get cold, because as it gets cold, I'm not taking matter out of the can, okay? I'm just allowing for a transfer of kinetic energy. So if an open system allows the exchange of matter, a closed system does not allow the exchange of matter. I think those are pretty straightforward definitions. Now, a new vocabulary word for us, isothermal. An isothermal system. The prefix iso tells us the same or equal. Thermal relates to heat or temperature. So an isothermal system is a system that stays at a constant temperature. Now, that doesn't mean heat doesn't go in and out, because actually a human body is isothermal. It stays pretty much at the same temperature. And when it heats up, there are physiological reactions that allow it to cool off. Okay? So we also have then an adiabatic system. And an adiabatic system is a system that does not allow the transfer of heat. Humans are not adiabatic. Now, your hydro flask, your thermos, those things do try quite hard to be adiabatic. They're not perfect, but they get close sometimes. All right. Now, heat capacity. We're going to think about this two different ways. First off, just kind of a general descriptive definition. Heat capacity is the ability of an object to hold heat, or the ability of a substance to hold heat. Water has an incredibly high heat capacity. Water is great at holding on to heat. It has to do with hydrogen bonding. Okay? Now, on a more technical level, heat capacity is the amount of heat necessary to raise 1 mole of a substance by 1 degree. So, water, high heat capacity. Metals, very low heat capacity. Metals heat up very quickly. They cool off very quickly. They are not good at holding heat. Now, some textbooks like to use the phrase specific heat. I never actually even saw that when I was in college. It wasn't until I started teaching that I saw that term. It's basically the same idea. The amount of heat necessary to raise 1 gram of a substance by 1 degree. So the only difference between these two definitions are whether we're talking about a mole of a substance or a gram of it. Not a big deal. Okay? Now, exo and endothermic, I'm hoping you remember. An exothermic reaction releases heat. An endothermic reaction absorbs heat. Now, you being the observer or part of the surroundings, when you grab a beaker and it feels hot, that's an exothermic reaction, because heat is being released and you are absorbing it. An endothermic reaction feels cold because the energy that it's absorbing is coming from you. Now, when we deal with things in and out of a system, we kind of use an idea like a bank account. If you make a deposit into your bank account, the number gets a positive sign. And when you make a withdrawal from your bank account, the number gets a negative sign. So anytime we put something into a system, we give it a positive sign. Anytime we take something out, we give it a negative sign. All right. Now units. Calorie versus calorie with a capital C versus a joule. We're going to do almost everything in joules. A calorie is the amount of heat necessary to raise 1 gram of water from 3 degrees Celsius to 4 degrees Celsius. A calorie with a capital C is 1,000 calories, or a kilocalorie, or what we might call a food calorie. That is what you read on the nutrition information on a candy bar. A joule, okay, is 4.184 calories. I'm sorry, I said that backwards. A calorie is 4.184 joules. Type that one backwards. Okay, 1 calorie is equal to 4.184 joules, and that is calorie with a lowercase c. All right, that is the end of page 2.